Here we are for geometry. Your geometry 11 section B, your part. I'm going to go over sections 11.4 through 11.7. A few problems to review. Trying to want to see some of the stuff worked out. Section 11.4. 11.4 talks about inscribed angles. Just inscribed angles, what you're actually looking at is when you have a circle and an angle, but that be touching the circle over here a little more cleanly. We can do this here. We got a circle, and we're touching that side. What you're not is something where the angle does the edge of the circle. It has to be, so not this little one down here, not this one, but this one. Okay, and what happens with those is we recognize the arc, the angle, inscribed angles. That means the arc, and if we divide it by 2, this is the measure of the angle. Well, let's look at, if we know that this arc right here is 102 degrees for this arc, this angle is going to be related to that somehow. The arc be equal to the measure of angle BAC. They're asking us to find. So we're going to take that and divide it by 2. By 2, this would be 51. So this question is going to be 51 degrees. That was similarly the angle for the other piece. Is 38 degrees, then the arc divided by 2 equals 38. So 2 equals 38. Arc CD sides by 2. 38 times 2 will give us arc CD. This would be, what would that be? 80 minus 4. That's, wow, this pen is up a little bit today. 76. So 76 degrees. 70. Let's try another one. For number 3 here, sort of FGH. So let's do that, and we have a darker green. How about, it's almost a little too dark. I think so. There we go. FGH is looking for this. Well, that figure something about this arc there. And the interesting thing about FG, and watching, what am I looking at? F angle in that arc, it's this, which corresponds to this arc. Well, if we look at those two pieces, arc is actually half the circle. How is a diameter FH as it goes through the center of the circle? So that means this is 100. That means that angle of that 90. I'm going to erase some of this so we can see the pieces that we need. For measure of arc JGF, so all the way around the other direction. Let's do the A, then we go to G, and then this other piece here. So JGF, arc JF, last piece, is going to equal 360. And I think I can, then maybe I can work my way backwards. This says 25 degrees. I'm going to guess that that's 20 down here. It's really pointed out, but I'm pretty sure that's what we're. If that's 25 degrees for angle JHF, that means this arc is. So if I fill that in, then we can figure out what the other piece is. We subtract 50, 60, the whole circle. We'll find out 10 degrees. So this is 310 degrees. Let's look at the next one. Now, because normally when we look at inscribed angles, we see actually on the circle. So we come down to a point when we think about going back to circle. But imagine it was dragged way back and we made a huge arc. It's actually the same type of formula. So this arc, we'll call that arc TS, but that's kind of, let's put another letter in here, RST. How about, so then arc TU divided by 2 equals angle are looking for. So in this case, that'd be 266 divided by 2. That would come out to, so this angle right here is 130. Now we have a different, because this is not just inside. When the vertex is inside, we have 2 arcs equals the angle. We never had them because we have 2 arcs here, 22. If we were outside, which will happen, arcs and subtract them, divided by 2 equals the. So looking at these 2 arcs, I have 100. So that's going to be the arc AC plus arc B divided by 2, that's 130 plus divided by 2 equals my angle. So 130 plus 22 divided by 2, that's 75, 76. 76 degrees, AEC. So this angle right here, 6 degrees. Now for this next one, I have so much going on, and I look at how the words, they give us a picture here. The MN is 102. So this arc here is 100. The measure of this angle be? Well, that angle is, notice if this arc is 102, the part that I'm making a dotted line with is going to complete the circle. And 60 minus 102. So this other half here would be 360, should be the same as 360, 58 minus 100, so it's going to be 58. Whenever I'm out, notice that the vertex is outside. They still have the two arcs, but this time we're going to, so it's going to be arc MN, the minor arc, minus, let's get another point out here, MN, how about O? MO, well, of course, because we want to put these in the correct order. We would have 250 minus 102 divided, it's going to equal that angle. Let's do some simplifying here. 258 minus, that's going to be 152 equals, it's going to be, how much is that? 75 plus 3, so that equals the measure of that angle. So this equals 8 degrees. Let's look at another one. Numbers. Now we're looking at segment relationships. Ourselves is an in, on, or outside. The first one I tell you is in. The second one is outside. How would we know if something were on the circle? If segments were on the, that means we'd have a line. The only way you can have a line that's on the circle is if like this. And it's very similar to each of these. Trying to make it calculate segments is it's always going to have the same pattern. Pieces multiplied together equals the other multiplied together. You just have to remember, get multiplied together. So for this first one, this length cut into two pieces. So we have for one of them, so x times 2 times 6. It's really that easy. X times 3, 2 times 6. Then this would on this side, and 3x on, divide both sides by 3 equals 4. It's straightforward. On the other piece though, it's going to be a little bit different. We have two kind of halves here. We got this piece inside. It's actually going to be 4 times the, which is 4 plus 3. We have 4 times 4 plus 3, and we can leave those together just so you see how this other one's going to be 3 times 3, multiply it by the whole thing here, 3 plus y. So if I were to simplify each of these terms times 7, here I can distribute. This is going to be 3y. So we'd have 20 plus 3y. So on both sides. We'd have, let's see how much we got on this side. Equals 3y. Is that correct so far? Yes, so far. So we divide by 3, and 19 over 4y. Now this actually happens quite a bit. We get these fractions in here because we have so many numbers, not as easy to make friendly. Calculations often come out with unfriendly number. 19 over 3. And this. Alright, now this one's kind of interesting. It's saying what's the diameter of the original circular wall that has these dimensions down here. It says ST is 12.2 meters all the way across. But that's not the diameter. It's just from S to T. It's a little bit smaller than the diameter. It says UR is 3.9. So this part right here is 3.9. So I really have a circle. Let's draw my own circle with not all this complex picture stuff going on. And I got two lines. One line goes pretty much straight like this, and then the other one's looks like it's perpendicular to it, and it actually is because those two pieces are bisected right here and right here. So that tells me that those two pieces are equal. That means this one's 6.1 and this one's 6.1, and then this piece right here is 3.9. The question is, how can I figure out the diameter? Well, if I knew that question mark, then I could add it to 3.9, and then I'd have what I need. Well, this is actually a calculation with segments, so we're going to have two pieces multiplied equals two pieces. And the other thing that I noticed too is, let's call this x here for the diameter, part of it. It's split here, the 6.1 times 6.1. And then the other piece I'm going to have a 3.9, and x. So if I do 6.1 times 6.1 and then I divide by 3.9 on each side, that's going to give me just x. Once I know that, I can add it back to 3.9 and then I'll have what I need. Well, let's see if I can pull up my calculator and get that going. You could probably even multiply it out. So we have our calculator loaded now. Let's go ahead and pull that up. We're going to be doing, it looks like 6.1 times 6.1 or 6.1 squared. And we're going to divide that by 3.9. We get looks like 9.5. So this is approximately, x is approximately 9.5. And then, so this over here, this is 9.5. Then the whole diameter would have been 3.9 plus that. So 9.5 plus 3.9, if we add those together, we should get about 13.4. That was our diameter for this relic looking piece. Kind of cool that you can use math to find pieces that aren't there anymore. Okay. Now we're going to be drawing circles real quick. We need to write the equation and look at what we have here. One thing to remember is that the equation of a circle, we have an x minus h squared and a y minus k squared, and then we got an r squared. We're going to add these two and equal to that radius. And as you're looking at this, you are given the h and the k and your radius. So when this says x minus h, that's actually x minus -2, and that's going to make it the opposite because then it'll be x plus 2 squared. So it was negative here, now it's positive. Same thing's going to happen for the other one, so that's going to be y plus 3, and we're going to square that whole group. And we have r squared here. 3 is r equals 3, so r squared equals 9. So this should equal to 9. That was pretty easy, pretty straightforward. It's just knowing your formula. And that's it. That's honestly it. You know, there are a couple of questions here and there that you probably should be looking at in the other video and such, but that's mostly it there. So it's just a little bit of extra stuff you can study. Please look over the other problems throughout the book, and we'll see you at the test.